You mentioned a love affair with mRNA, and that's pretty evident when we're looking at news relating to our food supply, especially. Late last year, a study explored the possibility of getting milk from vaccinated cows. It created a method to deliver mRNA through milk exomes. The study was funded by a Chinese lab company called Tingo Exomes Technology. But when mice consumed these milk exomes, the gastrointestinal tract absorbed the exomes and the mRNA made it into their bloodstream. So I asked attorney Tom Renz about this. He's been blowing the whistle about mRNA in our food supply, and he said this has the potential to go far beyond just cow products. Listen.
We've got another study. Potatoes, rice, bananas, tomatoes, lettuce, tobacco, alfalfa, algae, and bugs. You know, Bill Gates wants us to eat bugs. All seem to be real good vectors for transmitting mRNA vaccines. Are these gene therapies that they're giving the animals transmissible? Have they become transmissible? Who's watching it? Do we trust the FDA to make sure it's not transmissible?
So, Dr. McCullough, what kind of effects would we see from people eating mRNA and ingesting it via the food?
Well, let's address the Zhang paper, which I think is an inflection point. The Chinese, did two things. One, they took a shortened version of the messenger RNA, a 675 base pair of the SARS-CoV-2 spike protein code, and they were successfully able to make an exosome, a phospholipid packet out of cow's milk, get the messenger RNA to stabilize there. And then they were actually able to have the mice take in this milk over 3 different feedings spread out over 3 weeks. And sure enough, the messenger RNA got into the mammalian system, the mice system, and they produced antibodies in response to the protein made from that RNA code. So they have proof positive now that messenger RNA can be ingested and get across the gastrointestinal epithelial lining and into the bloodstream. This is a new dark phase of messenger RNA exposure to human beings. And I think Tom Renz is right. We should be very concerned about messenger RNA in the food supply. Now, we use genetically modified organisms, food, to grow big apples and big strawberries. The genetic use of technology to improve various forms of food, make them grow more readily. I think that's well understood. But the idea of using food as a delivery mechanism to humans and change something within the human body, that's a new aspiration. We're seeing it from the Chinese. I agree with Tom Renz. We actually need protections in bills. He's working on a House bill in Missouri to have protections in labeling to make sure that consumers understand what is in the food and give them the opportunity to avoid genetic loading of food, particularly if it's coding for something that can change a process in the human body.
Right. Speaking of the bill in Missouri, the National Cattlemen's Beef Association did release a statement in response to that, saying cattle farmers and ranchers do vaccinate cattle to treat and prevent many diseases, but that presently none of these vaccines include mRNA technology. The key word there, of course, being, Dr. McCullough, presently. Can we trust that it's not in the food already?
Well, we have to take the statements at face value. The concern would be if an animal received messenger RNA coding against, let's say, heartworm or some other form of a viral infection. That messenger RNA, we're finding out, Emerald, is far more durable than we ever could have imagined. It lasts in the human body for months, unchanged. It's made now with a synthetic, what's called pseudo-uridination, which makes it highly efficient but resistant to breakdown with ribonucleases. This means that food in various forms could actually have messenger RNA. Now the Chinese have shown that it can be ingested. One approach would be to ban all forms of messenger RNA technology in animals, period, so we don't have any threat of this coming through the food supply.
Yeah, and again, Missouri is working on that.